Hello everyone, here we are going to discuss about potentiometer. What is called potentiometer? You have any idea? Yes, potentiometer is also measuring the potential difference or EMF. We can able to measure the EMF, unknown EMF or unknown potential difference by using potentiometer. Then why we have voltmeter? Then why we need to go for potentiometer? That is a doubt now arises, right? Yes, there is a difference between voltmeter and the potentiometer. Has both are measuring the potential difference between some points, right? So similarly, there has some differentiation or some difference between an potentiometer and voltmeter. So what is the difference? Major difference mean the potentiometer is an ideal voltmeter. There is no potential drop across from the cells because it never consumes any current from the cell, but in voltmeter it draws some little bit amount of current to its operation. That is why there is some potential drop across the voltmeter, right. And the potentiometer measures the potential difference or EMF as accurately, which is equal to the EMF of the cell which we are using. But in voltmeter measures the potential difference, but which is less than the EMF of the we have chosen cell, right. Now we move on to this topic. Yes. So what is potentiometer? It is a device used to measure unknown EMF, electromotive force, or the potential difference accurately. This word is very important. We are measuring unknown EMF or potential difference as accurately by using potentiometer. Even though we have voltmeter, then why should go for potentiometer, right? There is some advantages of potentiometer over voltmeter. So what are the difference in the sense? Potentiometer, it is a null method device. What is null method device? Yes, if you are moving a jockey at one particular position in the galvanometer, the current becomes 0, right. That is why we are saying null method device. And when compared to voltmeter, it is not null method device. And at null point, it does not draw any current from the cell. Notify here, at null point it does not draw any current from the cell, and thus no potential drop due to the internal resistance of the cell. This is important for this potentiometer. At null point it does not consume or draw any current from the cell, and thus no potential drop due to the internal resistance of the cell. But in voltmeter it draws a small current from the cell for its operation, and thus there is a potential drop occurs in voltmeter. And the next important one is it measures the potential difference in an open circuit. Remember that it measures potential difference in an open circuit, and which is equal to the EMF of the cell. So the potentiometer measures the potential difference in an open circuit which is equal to the EMF of the cell. But in voltmeter it measures the terminal potential difference. Terminal potential difference in the sense we have the positive negative terminal, right, and we have the terminal potential difference which is less than the EMF of the cell, but in closed circuit. Here it works in closed circuit. So this one is applying in closed circuit, not in open circuit, closed circuit only. This voltmeter measures the terminal potential difference which is less than EMF of the cell when it is the circuit is closed. And here we are discussing about the principle of potentiometer. What is the basic principle it has, right? So there is a potential drop at any length, right, potential drop or the EMF drop at any length that is directly proportional to the length of the wire. That is the basic principle of potentiometer. Generally the potentiometer consists of 1 meter of wire like that, it is bending like that, zigzag, right. The wire will have, during construction part I will show this little bit demonstration for your better understanding. So what is the basic principle here? When a constant current current is constant. Try to understand all the words. When a constant current flows through a wire, right, of uniform cross sectional area, a steady current or a constant current flows through a wire of uniform cross section area and the composition. What is the composition here? Yes, the materials remains constant throughout the wire. There is no change in any composition in that wire. Suppose if you are taken as any metals, throughout the metal it is the same metal, copper. If we are saying copper, throughout the wire the copper, there is no any doping or any difference material is added in that material. That is why we are saying uniform composition. If it is so, the potential drop across any length, the potential drop across any length of the wire is directly proportional to that length. So, the potential drop at any length is directly proportional to length. So, here we are using a wire which is having 100 centimeter for every 100 centimeter is come like that. After that it takes some U bend, after that it goes to 200, similarly 300, take U bend, and similarly it goes like that. Okay. So, that potential drop across any length of the wire is directly proportional to its length, right. So, how to derive this equation? V is directly proportional to R, E is directly proportional to L, we have wrote here, right. The potential difference R EMF, that is directly proportional to L. So, how we can derive this equation? As we know that the Ohm's law, V is equal to IR, right? Yes. So, what is R? Resistance. I is current. V is potential difference or voltage. And we know that this R, the resistance R is directly proportional to length and inversely proportional to area. And if you are removing that proportional, then we have added one constant resistivity. Therefore, we can write R is equal to rho L by A, right. Rho is resistivity, L is length, A is area of cross section. So, what we wrote in that principle, when a constant current is flows, I is constant and through a wire uniform cross sectional area and composition. So, composition means resistivity, area of cross section means A. So, rho A is constant, right. So, V is equal to I, instead of R I am going to substitute rho L by A. So, again I can write V is directly proportional to L from that equation. So, if you are removing this proportional, I added one constant, that is pi. V is equal to pi L, R, E is equal to pi L, where pi is equal to I rho by A. Why? In the sense this I rho A, everything is constant, right. That is called this pi, that pi is called potential gradient. What is called potential gradient? The potential drop per unit length. Here we wrote, right, the potential drop across any length. That is why we are writing the potential drop per unit length pi, that is called potential difference. Therefore, from this equation we can write pi is equal to potential difference divided by L. So, here I wrote pi is equal to V by L or electromagnetic force divided by L, and this potential gradient having the SI unit of volt per meter, but practically we are taken as volt per centimeter. I hope you understand well this principle.